Okay, so let's pick up from where we talked about last time. Somebody remind me, what's the difference between A plus plus and plus plus A? Same thing? How are they different?
One adds the number first and then it like saves it, and one like saves the number and then it
Okay, so the A plus plus, if I were to print out A plus plus, it'll resolve to the current value of A and then add one to it permanently um, after. All right, so I get the current value of A, but A ultimately will have the effect of being one larger than it used to be. That's if the plus plus is after. If the plus plus is before, A immediately becomes one value larger than it used to be, and then I get the new value of A if I were to print it out. Does that make sense? So while both of these guys have the effect of adding 1 to A permanently, where the plus plus occurs, if it comes after or if it comes before, if I'm using that value immediately, for example, if I have int A is equal to 5, and I say system.out.println A plus plus. Now I'm recommending you never do this. That way you don't have to remember these little idiosyncrasies. All right. I would say always put A plus plus on its own line. That way it's never a confusion on what the new value will be. But if I print out A plus plus here, what value will print out? 5. Okay. If on the very next line I print out A, we will see that A has changed to 6. All right, so this is going to be a 5 followed by a 6. Since the plus plus came after the A here, this print statement will resolve to the current value of A. So I'll print out the current value of A before ultimately changing A to a value that's 1 larger than it used to be, which we proved right here. Make sense? The alternative is if I said plus plus A, this will change the value of A first, then resolve to the new value. So now I'll get 6 and 6. That makes sense? Okay. Now, I'm telling you, never, 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 never have to deal with this in real life if you don't try to get fancy in including the plus pluses inside of another expression. All right. You might have to deal with it on a quiz or an exam or something like that for one question, just so you show me that you understand the difference between these guys. But a good programmer won't necessarily try to show off by doing things like this. Every now and then, you might run into a situation where it actually is substantially more convenient to go ahead and embed it. But when you get to that point in time, I promise you'll be confident enough that you will know the exact difference between them. But in general, if you want A to be 1 larger than it used to be, what will that print out? It'll print out 6. Why will it print out 6? Because I'm changing A here. This will boil down to the current value of A, which is 5. Then A will be 1 larger than it used to be, which is 6. But I'm not using the value that this boils down to. I'm not doing anything with it. I don't use it till right here. So by the time I get here, A is already 6. So there's my 6. If I say plus plus A instead of A plus plus, I get the exact same output. So when we put it on its own line before we actually try to use the value, they have the same effect. We didn't have to remember what happens when I do it before or when I do it after. Now, something that's interesting, as a generally, so programmers in the know. So for instance, us now, we understand that there's actually a difference between plus plus A and A plus plus. Now, many programmers that are in industry, they don't understand there's even a difference. It's just however they learned it, probably from a book or something. right? So one thing you'll see is most modern programmers, so assuming you're not trying to do the trick of what it resolves to right now, most modern programmers will do the A++ thing. The plus plus comes after. That just tends to be the modern way of writing increment. But you go back sometime to maybe the 70s, so the old C and C++ days. The common thing was plus plus A. Yeah. So yeah. So I don't necessarily know why. I don't have a rationale for that. That's somewhere in there. But now at the same time, back in that's called the older days, when in the 70s and 80s, it was very common for I guess I would characterize it as programmers to show off. Use hard to understand variables or write lines of code that weren't immediately obvious what they were doing. You had to look at it to kind of deconstruct it to understand it, right? And at the end of the day, nobody's actually impressed except probably them and like their one buddy that eggs them on or something like that. All right. Now, computer science folks, we're just like, we're just like athletes. You got the star quarterback. Now we're walking out of the hall. Everybody, we got the that doesn't happen. So now that everybody just thinks we're geeks. Yeah, we just think we're geeks now anyway. So there's no cool factor anymore. So okay. So I'd strongly encourage you, if you want to increment a variable, increment it on its own line. Now it's one bigger than it used to be, no matter where you put the plus plus. Okay? Questions about that? All right, so we've kind of covered this first part of how do we remember things. Now let's talk about asking questions. We're giving ourselves those 3 tools: remembering things, asking questions, and repetition, so we can start solving problems in Java. So ask questions. The syntax for questions in Java is something called an if statement, which is similar to what you learned last semester in Python. So it'll be if, opening parenthesis, Boolean expression, closing parenthesis, opening curly brace, list of expressions, closing curly brace. And then optionally, we can have an else with an opening curly brace, list of expressions, closing curly brace. But the else is optional. All right, so remind me, what's a Boolean expression? We said this over and over and over again last semester, right? What's a Boolean expression? Any expression that boils down to a single value of true or false. All right. So sometimes Boolean expressions look very simple. Sometimes they look very complex. But ultimately, once you resolve it, they come down to a single value of true or false. So we use these guys to ask questions. So let's look at some examples here. I might ask the question, if A is less than 10, system.out.println, call this small a. Something like that. So right now the value of A is 5. Is 5 less than 10? Yes, it is. So this Boolean expression right here boils down to true, a single value of true or false. Since that's true, we will execute what's inside of the true statement here. Okay? Else, well, actually, let me, common mistake people make. So I've mentioned an optional else, but I haven't actually put the else in here. But it's common for beginning programmers to assume that anything that comes right after the if is part of that else. If you remember from Python, we did things with indentations, right? That doesn't exist in Java. Java is perfectly happy with us putting all this stuff on a single line, although I strongly encourage you not to do that. Okay, single lines are not easily readable by humans. All right, so right now A is 5. Is 5 less than 10? Yes, it is. So it'll go ahead and print out small a, and then it'll also print out large a. Because once it's gotten past this little checkpoint, you can think of this as a checkpoint, we're not guaranteed to execute this code here, but in this case we do because this Boolean expression is true. Then we continue on with our program, and the next thing says large a. So this will print out small a, then large a. If I make a 50, is 50 less than 10? It's not, so we'll skip over this part of it, and we'll just print out large a. Now, if I throw an else in here, and I wrap the large a portion inside of that else, a is 50, we're going to get large a. If a is 5, I'm just going to get small a. This else, this is the stuff that happens when this is false. This is the stuff that happens when this is true. So since a is 5 less than 10? Yes, it is. It's going to do this stuff and skip this. Make sense? All right, questions about if statements in Java? Go ahead. You're about to ask whether curly braces are required, aren't you?
Yes.
All right.
For the one line.
Yeah, so in this particular case, this is legal. That will have the exact same result. So will this. So will this. This should look horrible to us, right? Those all have the same result. So will this. Now, the reason for that is this. The official syntax, this is a multi-line comment when you do a slash asterisk and then a asterisk slash, so we can put multiple comments on, in a row. The official syntax for an if statement is if, opening parenthesis, Boolean expression, followed by a statement. That's the official syntax for an if. Now, statements come in many different forms. For example, this guy right here is a single statement. That's why that's a legal if statement. Now, the common statement that's used for if statements is the block structure. That is the statement that is the opening and closing curly brace, which is effectively a collection of statements. All right. Now, what I'm going to tell you is it's always required to put those curly braces in there. Even though in Java or in C or in C++, that's not a true statement. In Java and C++, and C# even, a single statement does not require the curly braces. First of all, this looks better. All right? Having the curly braces there shows you that this stuff in here is a collection that belongs to the true part of this if statement. Indentation looks better this way as well. So even though Java doesn't require indentation, a human being, when they look at it, will appreciate indentation. And you'll notice that Eclipse does a lot of the indentation for you. Now, what you will see in some books is a syntax that looks like that, where the opening curly brace is on the line up here, the closing curly brace is below here. This is also a common way of writing it. I strongly prefer and would recommend you write it like that so you can see where the curly brace starts, where it ends, and you know everything between these two belongs to the true statement of that Boolean expression. But at the end of the day for Java, they don't care if you put it all on one line. This is only for human eyes the humanized situation. Now, whether you use the curly braces or not when you have a single statement, I don't care. Officially, Java allows you to have one statement without the curly braces. But what I'm telling you is that, for example, even though we have this indented all nicely and stuff like that, like we might be used to from Python, what we have written right here is very different than that. And to show you that, if I run this right now, I'm going to get a is 5, 5 is less than 10. I am going to get small a followed by large a, right? Now I'm going to change this to 50. So a is equal to 50. Is 50 less than 10? It's not. What's going to print out? The small a will not print out. The small a is the single statement that's owned by this if statement. So because a is not less than 10, this guy is false, so we will not execute this line. But we will execute this line. So this will say large a. Because even though we have it indented and it looks like it's part of that if statement, it is not. So this says large a. So that is different than if I put the curly braces here. And now both of these guys belong to the Boolean expression here. So I've clarified what my indentation implied before. So now nothing will print out. Because both of these statements belong to the block of statements associated with this Boolean expression. That makes sense? So this is another thing similar to the whole plus plus argument. It is never, ever, 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 ever wrong to put the curly braces. So always put them. Always give yourself an opening and closing curly brace after an if statement, and then throw the stuff into those curly braces that you want to be associated with that if statement. If you don't want them to be associated with an if statement, don't put them inside the curly braces. Problem solved. Then you don't have to worry about possibly misleading yourself with poor indentation. And this is another, so let me use this opportunity to give you kind of another warning, if you will. Even though Eclipse does a lot of indentation for you, you know, when I write this if statement, so let's say I started writing it up here, and I press enter, and I go ahead and I put that curly brace in, notice it gives me the closing curly brace and also indents me inside of it. I don't know what students do, but they fight this. they fight this auto indentation thing to the point when they turn stuff in, there's crap all over the place. So I'll have stuff all the way back in here. You know, you'll have this curly brace will be down here. This guy will be, maybe over here. I mean, it's just like all over the place. And it's probably a combination of cut and pasting stuff from Google or what, I don't know. I don't know how it happens. But whether Eclipse indents it for you or you indent it yourself, indentation is very, very important. And the reason we chose it, well, one of the reasons we chose a language like Python for that first course is because Python strictly emphasizes indentation, correct? We had to use indentation with Python. It was part of the syntax. So indentation is very, very important. In Java, it's not important for correctness, but it is going to be important for readability. And what's most important for you right now is that you can read your own code, that you can look at it and decide, what is this supposed to be doing? That makes sense? So make that a high priority to keep your code clean, indented. I don't care if you put the curly brace up on, this line versus, underneath it. I'm encouraging you to put it underneath it like this. and then have the matching curly brace directly below it. That would be what I would encourage you to do. I find that to be easier to follow, but you know, if you like a different approach, that's fine. All right, questions about any of that? So curly braces are never going to be wrong with if statements. So I'd encourage you to always use them. If you want to be fancy, and when you only have one statement and not put them in there, that's fine. I can read it. Okay? But I promise you, beginning programmers are going to run into situations where you might look at your code and think it means one thing, but it actually means something else. That's a skill that you're going to get over time. And especially when you're indenting and your indentation implies that your code means one thing when it actually means something else. Okay. And then, like I said, optionally, we can have the else and have our open and closing curly braces there. So, you know, we can do our system.out.println small, steal this. Call this large. This gives us a one or the other, but not both situation. So since A is 50 less than 10? It's not. So we'll jump down to the else. This is what we print when this is what we do. In this case, we're printing something when the Boolean expression boils down to false. So this will print out large. If I change this back to a 5, this will print out small. So with a Boolean, with an if statement, either this guy will happen or this guy will happen, not both. All right, questions about that? So now we've covered asking questions. What about repetition? Let's talk about our different loops. So in Java, we have 3 different loops. We'll say loops. I'm going to put repetition here. Now, loops are kind of like if statements in that we still use that Boolean expression. Boolean expressions allow us to ask questions. All right. Now, the if statement allows us to ask a single question and respond to it once. Loops allow us to ask a question and respond to it over and over and over again. Maybe we're counting down from 10 to 0. Okay. Our counter is currently 10. Is count greater than 0? Yes. Do something. Subtract 1 from count. Is count still greater than 0? Yes. Do it again. Subtract 1 from count. Is count still greater than 0? Yes. Do it again. So on and so forth. So it allows us to repeat the same section of code over and over and over again as long as some condition remains true. So we have for loops. We have while loops. We have do while loops. Now, we also have something called a for each loop that I'm not going to introduce yet, but you will eventually be introduced to it. All right, that has something more to do with collections of things. So that'll make sense when we get there. But let's look at let's call these our primitive loops. It's so nice of it to just auto-capitalize even though I wasn't on that line. Okay, so for loops and while loops, very similar to each other. These are pre-check loops. A do while loop is a post-check loop. And what I mean by pre-check versus post-check is pre-check says we're going to test the Boolean expression before we execute the body of the loop at least once. All right, so let me show you what I mean by that. So I might write a for loop. So the syntax for a for loop, I'll just do it in here. So it's the word for, all lowercase, followed by an opening parenthesis. Now there's 3 parts to the for loop. So we have what's called var creation, followed by a semicolon, followed by Boolean expression, followed by a semicolon, followed by var change. Closing parenthesis, opening curly brace, closing curly brace. Same rules apply with the for loop. If you only have one statement following it, you don't actually need the curly braces. It's never wrong to use them. So always use them. Okay? So let's look at what I mean by this. One thing I might say about for loops is these guys are self-contained. And that's often a good thing, but also has some consequences, and we're going to talk about those here. And I believe we looked at for loops. Python, we didn't look at normal for loops in Python. We looked at, it was effectively a for each loop. So we'll cover it again here anyways. We probably talked about some of this a little not last semester, but let's cover it again real quick. So this guy's self-contained. So let me show you an example of counting from 1 to 10, something like that. So we're going to say for int I is equal to 1, I is less than or equal to 10, I plus plus, and we'll say system.out.println I. So that's going to be our first for loop here. I'll go ahead and hit play. So this is going to start I at 1 and count all the way up to 10. This is where I created my variables. In this case, I'm creating one variable. We are allowed to have more than one there. We can also have 0. We can leave that part completely blank. And sometimes you might want to do that, but then I might start asking why you're using a for loop, and that'll make sense here in a few minutes. Then we have the test. This is the Boolean expression. Just like an if statement, except this guy's going to get asked every single time we come back through the loop. And then we have the portion where we actually are changing our variables. If we don't change our variable here, we'll have an infinite loop, right? If I choose not to put the I++ here, now this guy runs forever. It's just printing out 1 every single time. I started off at 1. Is 1 less than or equal to 10? Yep, print it out. Is 1 still less than or equal to 10? Yep, print it out. 1 still less than or equal to 10? Yep, print it out. Probably not the best way of handling this. Stuck in an infinite loop here, you get the little red stop button here. Go ahead and click that. So it's important that when you write loops, those loops have a terminating case. They eventually finish. Otherwise, you get that infinite loop where your code never completes. Sometimes that's fun. So we put the I++ there. So this is where we change our variable for a while loop. So I starts off at 1. It's a pre-check loop. So we ask this question before we print out the value even the first time. Is 1 less than or equal to 10? It is. Print out the current value of I, which is 1. 1 becomes 2. Is 2 less than or equal to 10? It is. Print out 2. 2 becomes 3. Notice I'm not going back to this section. This section only happened one time at the very beginning. Is 3 less than or equal to 10? Yes. Print out 3. 3 becomes 4. 4 less than or equal to 10, so on and so forth. Till we finally get to, is 10 less than or equal to 10? Yes, it is. It's equal to it. So we'll print out 10. 10 becomes an 11. Is 11 less than or equal to 10? It's not. So we're done. So what will print out right there? If I print out I after that for loop, what's going to display? It's going to be an error. Don't let the red squiggly thing trick you. Yeah, it will be an error. But the logical thing for us to have said would maybe be, oh, it's going to print out an 11, right? I became 11. Is 11 less than or equal to 10? No. So we're done. We fall past this, and we're going to go ahead and try to print out I. I should be 11 by then. But it's yelling at us, and it's going to say it doesn't know about I. I hover over this guy, and it says, I cannot be resolved to a variable. I've never heard of it. What is variable scope? We talked about variable scope last semester, right? What does that mean? What's a simplified definition of variable scope? We did talk about it, right? Remember that phrase at some point? Such a lively crowd. Okay, so that's part of it. So all variables resolve to their most local definition, right? So wherever we've most recently created a variable, That's what it will resolve to. But only, so this is where the scope parts comes in, only within the scopes we have access to. So simple definition for scope might be where we have access to a variable. Okay? Or what area does a variable make itself available to? What happens here with a for loop, since we're defining this variable I inside the for loop, we get this little local scope that comes with the for loop that lives and dies with that for loop. So I have that thing highlighted right there. And when this for loop is done, I dies. We don't have it anymore because it was created as part of this for loop. Now, if I take this out of here and I paste it before there, okay? I mentioned you don't have to put something inside. I do need the semicolon here. You don't have to have something inside the variable creation part, but then I mentioned a few minutes ago that I might ask why you're using a for loop, but you know, there might be still a valid reason. Now notice this guy's happy again. It'll print out the 11 this time. So there's my 11. That's that guy right there is this right there. Why is that? Now I defined I as part of the local scope defined between these two curly braces. Now, this isn't a 100% truth, but let's call it a 99% truth. Every single time you see a set of curly braces, in fact, I'm going to show you an example where it's not a truth here in a minute, but you know, very often this is the truth. Every single time you see an opening and closing curly brace, a new scope was born. Okay, so here's one variable scope where I have highlighted now. So anything that's defined inside of here is then available to everything from that point forward. So I define the I right here. So from this line forward, still inside of this opening and closing curly brace, I can use that variable I. Okay? Here's another opening and closing curly brace. That's a new variable scope. Now what would happen if I said int I is equal to 5 here? He's no longer happy because he's saying there's already a variable named I. I can't overwrite that variable because there's already one inside of this scope. That makes sense? You're going to use a for loop most of the time. You want to include it inside of the, you want to include your definition inside of that loop there. Now, so that means you can't access it outside of it like this, but why is this kind of a nice thing? If I copy that, well, let's start it off at 10, and we'll say keep going as long as it's greater than or equal to 0. And then we say I minus minus here. Now it'll count from 1 to 10, and then it'll count from 10 back down to 0. And I used I both times. So what we're dealing, for loops typically lend themselves to counting type problems. That doesn't mean we can't use it for other stuff, but usually we're doing counting stuff. Now, in the big scheme of things, isn't I kind of a throwaway variable? We're using it for the moment. We want it to count from 1 to 10, but when we're done with it, toss it, right? We don't need that guy anymore. But it's kind of a nice little variable to go back to. So in programming, you usually have 3 counting variables that are our common counting variables, I, J, and K. Okay, the reason we only have 3 is one use of for loops, having nested for loops, a for loop inside of a for loop inside of a for loop, is for dealing with 3 dimensions. So you might have an array of arrays of arrays. Forget about that for a second. We could just think about it generically for us as 3 dimensions, right? Well, if you go to a 4th dimension, our brains go into an infinite loop. And we have problems with that. So that's why we typically don't do things with 4 dimensions. So generally speaking, we only need 3 unique counting variables. Because if I have another for loop inside of this for loop, I can't use I again. So that's when I use J. And if I have another loop inside of that, I can't use I or J again because those guys are already used in the scope. So I would use K. And then we typically wouldn't do it anymore. We wouldn't have more for loops in there. Okay, so those tend to be our go-to variable names. It's in no way required. That just is the common practice, if you will, to use I, J, and K for throwaway counting variables. For us in here, for a very, 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 very high percentage of the time, we're going to always use I. You can name it something else if you want. You can call it int count equals 0 if you want. It doesn't matter. But when you look at examples online and stuff like that, you will find I is often used for a throwaway counting variable. Okay, so we understand variable scope to a point right now. We're going to get lots more practice with it. We're going to kind of see it in the context of Java, even though we dealt with it in Python, but that's been refreshed in our mind, kind of what that guy means. All right, so this is our for loop. Now, as we already said, I lives and dies with that for loop. So a temporary scope was born with that I right there. I'm going to write the equivalent code to that as something called a while loop. While loops are also pre-check loops, so they really behave very similar to a for loop. They behave very similarly to a for loop. But the syntax for a while loop is while, opening parenthesis, Boolean expression, open curly brace, closing curly brace. That's the official syntax for a while loop. Now we have a couple of pieces missing there that we don't necessarily, that we know we're going to need at some level. We've already discussed that we definitely need to have some way for our loop to end. We need to have a terminating state for our loop, right? Otherwise we get the infinite loop and then we don't have to worry about how good our logic is later on because your program is broken up here, okay? But realistically speaking, we're probably going to be doing stuff inside of this while loop here that will eventually make this Boolean expression false. Okay? Similarly, we may be working with a counting variable. So we might have to predefine a variable up here that we then use in this Boolean expression and further use inside of here. Now, a few minutes ago, I mentioned something about pretty much every single time you see an opening and closing curly brace, there's a new variable scope. That is not the case with a while loop, or a do while loop for that matter. To be honest, I don't know if off the top of my head I can come up with any other examples. It's just kind of those don't create temporary variable scopes. I might almost say that the reality here is that the for loop is treated as a special case because its syntax supports the definition of variables. So the way it was implemented is to, and we talk about this in the 470 class when we create for loops in there. Because of the stuff that a for loop comes with, those tools for defining variables, it's forced into creating its own local scope. Because that's not part of the syntax of a while loop, there isn't a reason to create a scope. We would have to go out of our way to redefine the block statement to say this guy is a variable scope. So what I'm telling you here is that the block statement itself, this idea of an opening, closing curly brace, that's not the dude who actually creates that variable scope. He just happens to be present a very, very, very high percentage of the time when we're dealing with a new variable scope. The dude that actually created the variable scope, for instance, up here, was the method. The guy who actually created the variable scope up here is the class. That just happens to be followed by that block structure. All right, so generic definition for a while loop looks like this. Let's go ahead and write a while loop that behaves the same as this guy up here. So we're going to say int I is equal to 1. And notice I'm allowed to use, well, let's see, where do I have, okay, we're fine. We're allowed to use I there. It's just complaining to me right now that I've created it and never used it. The value of local variable I is not used. That's a warning. Code would still run. Okay, so I'm going to say while I is less than or equal to 10. So same exact Boolean expression I had above. Of my opening and closing curly braces. Now I'll say system.out.println I, and then I'll say I++. If you wanted to be fancy with this, you could have said I plus plus right inside of there. And because all of us know how plus plus works, we know that this would print out the current value of I and then change it, right? But we're not going to rely on that because we're conscientious programmers, and we're going to go ahead and print out I in its current state. And then we could say I plus plus, we could say plus plus I, we could say I plus equals 1. We could say I is equal to I plus 1. Just pick your poison. Those all mean the same thing. We're adding 1 to I and storing the result back into the variable I. Okay? So now notice what we've effectively done here is we've visited the same parts of this for loop in the same order that the for loop visits them, but we've done it with a while loop. This guy happens before we ask the Boolean expression, and it happens exactly once. Then we ask our question. This guy is a pre-check loop, so we always ask the question before we execute the body even once. So I is currently 1. Is 1 less than or equal to 10? It is. Go ahead and print out the current value of I. I will resolve to its current value, which currently is 1, so it'll print out a 1. Then we're going to say I gets the value. This is the assignment operator. I gets the value of the current value of I, which is 1, plus 1, which is 2. Assign that value back into I, so now I permanently holds 2. And then we spin back up. So the very last thing we did here is change our variable, which is the very last thing we did here. That make sense? So we happen to have put the code in the right order that it literally mimics what these two guys do. So up here, this is going to print out 1 to 10. Down here, this is going to print out 1 to 10. So there's my second 1 to 10. There's my first 1 to 10. Make sense? Now, as written, are these two loops identical? Are they is one just as good as the other? Are they completely, functionally identical to each other? We saw that the output is the same. But there is one little caveat to that while loop that makes it just a little different than the for loop. And what is that, based on what we've talked about so far today? Is that allowed? That's allowed there. Was it allowed up here? It's not. My variable I here lived and died with the for loop. Therefore, when I got to this line, it's never heard of I. Down here, though, I is not part of the scope of the while loop. In fact, the while loop doesn't have a scope, as we already discussed. So I is actually part of the scope of this main method here. So from this point forward, while we're still inside of the main method, we have access to a variable called I. So now I can say, well, I is less than or equal to 10, blah, 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 all the same logic. But when I get to here, it has heard of I. And now it'll print out that 11 for that second one. Make sense? Now, what will happen if I take this for loop from up here and I just move it after the while loop here? Should it matter which order they come in? Depending on how clear it is up there. We see it. We might think logically it shouldn't matter, but it does matter. He's not happy. This for loop is not happy. Why? We already have an I in this scope. You can't build a new one. I is off limits. We can't use this guy. He wasn't off limits when we had it up here because we hadn't previously defined an I. from this point forward inside of the main method, inside of that scope, I now exists. So when we're up here, there was not a previously defined variable named I, therefore he was free to use, so we used him here. He lived and died with our for loop here. So we were able to define him fresh right there. Now, what if I had moved this before the for loop? Now we see that our for loop is cool, but this guy's not happy. Because, again, I'm trying to redefine I. Because now I've decided not to use the local scope of the for loop to define a variable. Instead, I defined it before the loop, making it part of the scope of the main method from this line forward, from line 12 on, while we're still inside the main method. So from line 12 to line 31, I have access now to a variable named I. And when I get to line 24, I'm trying to define a variable named I. But now the issue is if I want this loop to do some new logic, I really need to change the value of I. So what do? Well, just change the value of I. It's a variable. That's what you can do with them. I don't need to redefine it. I already have it. I have a variable named I. I'll just throw a 1 in it. Whatever it used to be, we know it used to be an 11, right? Just because of whatever previous loop does. Now we just change the 11 to a 1 so we can start over. But we weren't allowed to redefine it. We're just repurposing it, if you will. That makes some sense? Okay. Now, I know I told you this last semester as well, but I'm going to reiterate it now. This is, this kind of goes hand in hand with some of the things we've talked about with some of the indentation stuff. One thing that beginning programmers often do is, you Google things a lot, and that's fine. I'll find out in the exams whether you're learning stuff. So frankly, I don't care how you get to the answers in the homework, because the final answer in the homework is the least important part of it to me. Okay? What I want to see in your homework is you going through the reps, going through the hell of writing it, feeling like you suck at it, making mistake after mistake after mistake, but over time you end up getting better and better and better at it without even knowing. Right? This is like a sport. I want you to go through those reps. I don't care what your final answer is. If you've done a reasonable job on the homework, you've put in reasonable effort, that's why I have you fill out that self-evaluation. Okay? Tell me how hard you worked on it. Okay? Tell me what you think you deserve based on your solution, and now describe your experience to me so I can look and give you some feedback based on, maybe whether you're kind of going about it the wrong way, in terms of, you spent 6 hours on this, but was it 6 good hours, or could you have spent 2 good hours and gotten the same output, something like that. I'll find out on the exams whether you're learning the stuff. That's where you're going to take your hits on your grades, right? is on the exams. As long as you're working hard on your assignments, you're going to find that you most often get a better grade than sometimes you deserve based on what you submitted. Now, having said that, since students often go to the Google to find answers and look for stuff, there's a couple of caveats to that, a couple of problems with that. One is I'm not telling you not to go and look stuff up on Google. It's good. I mean, this generation has a resource that previous generations didn't have, right? We didn't have the when I was a kid, we had physical encyclopedias up on the wall. Now, how soon after those encyclopedias were purchased were they out of date? Right away, right? Now we're we flip the coin whether Wikipedia is lying to us or not, right? It's something like that. But the punchline is we have a great resource in Google. So I think too often teachers view Google as a big negative thing. We're all professionals at using it. Use it. If it helps you learn, if it helps you get this stuff, use it. But the thing that I would really, really, really encourage you to do, at least early on when you're coding, don't copy and paste from Google. Type as much of the stuff as you can to get yourself used to throwing semicolons at the end of lines, the opening and closing curly brace thing. That's that repetition stuff. So that goes back if you're trying to learn tennis or learn golf or something like that. You can't just watch somebody hit 300 forehands, and then through osmosis, you can do it now, right? That's the copying and pasting thing. Write it yourself. And as soon as it gets to the point where you feel like it's super tedious and why am I wasting my time doing this, then you can go ahead and start copying and pasting, because now, hitting a quick forehand is not a big deal. You're not going to remember the semicolon. You're not going to forget the semicolons very often. I mean, I forget a semicolon every now and then, but pretty often I accidentally throw the semicolons at the end of the line because I've written that stuff so many times, it's just second nature. Once you get to that point, then give yourself permission to start copying and pasting. It's not a big deal. But, do give yourself every opportunity to type stuff early on. The other warning I'll give you about copying and pasting in some programming languages is sometimes certain symbols will come in differently than they appeared. And a good example of that is, let's say you copy from Google and you're copying the string hello. It'll actually come in as, I don't even know if I could reproduce it, something like that. It doesn't grab the double quote character. It grabs some sort of other Unicode character that looks like it, and then you get this weird error, and you're looking at like, what's wrong? They look way closer to each other than what I've just produced here. But just fair warning, sometimes when you copy, you'll get little symbols like that will copy funny. It'll never be letters and numbers. It'll be like either single quotes or double quotes. That's the real common ones, those two. So just be aware that if you're copying things like that, kind of double check. Usually Eclipse will highlight the thing if it doesn't know what the heck you're talking about. But be aware that that's probably the error. You have to just go in and backspace what it thought the double quote was and just replace it with the new one. Make sense? I promise you that will save you 2 hours at some point in your future life. Ask me how I know. All right. All right. So now while loops, similar to for loops. Pre-check loops, we ask the question first, blah, blah, blah. Now, while loops, though, they lend themselves to a different kind of problem. So even though we've used it for a counting loop and we realize, we see here we didn't have to reinvent the wheel to do it. It worked fine for counting. While loops don't necessarily lend themselves to counting problems. They kind of exist for problems where we don't know how many times we're going to have to spin through. So for loops, we usually say counting problems. While loops, we don't know how many times to spin through, so maybe we say until some event occurs. So, for example, this might be, a wait loop where we're waiting until some button was pressed. All right, something like that, or till the mouse was clicked, that kind of stuff. So we don't know. They could press a button in 2 seconds. They could press a button in 20 minutes. Now, really, a while loop isn't the greatest tool for that. Even though it's a good example of a circumstance where a while loop could play in. Waiting for a button to be pressed, it's actually it's a pretty poor use of a while loop, because the while loop, your computers are really fast today, right? So that while loop's going to run many, 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 many times per second. One of us in here is going to have the fastest reflexes, right? It's not me. Okay, so but whoever has the fastest reflexes, you're not going to hit that button that many times in a second, right? It's always that person who plays like Xbox or something, and you just like, how do they press the button that fast? It's ridiculous. It's not as fast as your Pentium processor can keep tabs on whether or not you've pressed the button. Yeah.
So, just going back a bit, do conditions have their own little scope?
If statements, no, they do not.
Okay.
No, if statements are like while loops.
All right.
So in fact, out of all these tools, the only one that has its own scope is the for loop. There might be something else that pops up at some point, but what's readily occurring to me right now, it's just the for loop is treated as the special case. Other than that, it's methods and classes. That's where your scopes come from. Okay, so a better use for a while loop might be if there's some other part of the program, and these are like more multi-threaded programs, or some other part of the program that something's occurring, and you're kind of waiting for some value to become available or something like that. So you really can't progress in the program until that happens. Maybe a while loop is kind of a rudimentary way of pulling that off. Okay, so the punchline is that if we're really thinking about modern programming, a majority of your loops are going to be for loops. Most of the time when we're writing something, we're repeating something a fixed number of times, or we're going through I might say a known number of times, but it might be we want to loop through every element in this list. We might not know if there's 5 elements in there or 300 elements in there, but at runtime, Java will know. We're going to say we want to go from 0 to the length of this list minus 1. Go through all of them. All right, so now the for loop then has a fixed number of times it's going to go through stuff. So you're going to find for loops to be extremely common entities inside your programs. While loops will be a little bit less common. Well, probably substantially less common. Not that they don't have a place, but you won't see them as often. But we've already seen that you can do anything with a while loop that you can do with a for loop. Having said that, what's the advantage of a for loop over a while loop? We've kind of said that we've kind of done it a bunch of times today, but if we really had to articulate it, why might you choose a for loop for counting problems over a while loop? Go ahead.
More succinct syntax. It's just smaller, cleaner.
Okay, that's not a wrong answer. I mean, certainly it's everything's kind of packaged together, but there's an additional caveat to that. Why else? Kind of comes back to that scope thing. I mean, when we're counting through, if we're doing a lot of counting stuff, go ahead. Yeah, that's it. That way later on, when we want to count again, we can just create I again and move on with life. We don't have to worry about that, well, there already was an I, so let me just repurpose that and reset the variable. You just create it again because the other one's gone. You needed it for a second, you finished it. It's kind of like a coffee stirrer, right? You finish stirring and you toss it because otherwise it pokes you in the eye when you're drinking it. So, in any case, that's your while loop. Now, do while loops, these guys work a little bit differently. It's called a post-check loop. And what that means is that we actually ask the Boolean expression, we ask that question after we've gone through the body at least one time. All right? So, we might say, when something needs to happen at least once. Syntax for these guys. Do opening curly brace, closing curly brace, while Boolean expression, and then there's a semicolon there at the end. Okay, so for example, we can say I is equal to 1 because we're repurposing the I from above. Do system.out.println I plus plus. And we're going to keep going while I is less than or equal to 10. Like that. So this would be, let's call it the almost equivalent do while loop to what we had above. Okay, so we had I is equal to 1 up here. We counted from 1 to 10. We reset I to 1. We counted 1 to 10. We reset I to 1. We counted 1 to 10. Now, what would happen if I made I 50 here? What would happen to this for loop if I was 50? It would do nothing because it's a pre-check loop. Okay? We ask the question, we say, is 50 less than or equal to 10? It's not. We're done. Don't execute the body even once. It's a pre-check. What if we say I is 50 here? What happens here? Same thing, skips. It's a pre-check loop. Is 50 less than or equal to 10? No. So zip past all this, keep going. Now we change I to 50 here. What happens here? Yeah, it's a post-check loop. So the very first thing we'll do, print out 50. 50 becomes 51. Is 51 less than or equal to 10? Nope, we're done. So we will get an output from that because we had to do it at least once. Understand the difference between the pre-check and the post-check loop? Do-while loops, it's kind of an interesting trivia thing. They are you will find them to be the least common loop found inside of source code for programs, but it also involves one of the most common problems. It lends itself to one of the most common problems we run into in our modern day programming. So if do-while loops lend themselves to problems where something needs to happen at least once, can you give me an example of a problem that needs to happen at least once? Common example. Most of you, well, it's 10 o'clock and, well, yeah, it might be a little early. Some of you haven't done this yet, but most of you will do this at least once today. In fact, I think it's highly likely all of you have done this today, even if it happened automatically for you on your phone or in your laptop. It still occurred. Anything that has to happen at least one time? Just gotta check what's going on. How many of you checked your email today? Okay. What has to happen at least one time when you check your email? It's to sign in. It's to authenticate. You're going to toss it a username and password, even though I understand it's saved on your machines and it sends it behind the scenes. But it's going to try to sign in with the username and password. And presumably, if it saved it, it's going to get it right the first time. And then it's going to let you in and check the email, right? But if you get it wrong and it spits back bad username or password, then you got to give it to it a second time. So authentication is a super common thing that we run into today. So do-while loops are perfect for authentication type problems. Keep trying until you finally get in. That type of thing. All right, questions about that? Okay, so that's loops. So now we have creating variables, so memory, asking questions, and repetition. So now what we're going to do is we're going to write a function. So last semester we had functions in Python, right? Okay, what is a function? What's the definition of a function? Or a definition of a function. Go ahead.
So a definition would be a piece of code that you want to run many times, and so you call it and run it.
Yeah, you write it once. So it's it's a chunk of code that we write one time, and then we call over and over and over again, potentially passing it different inputs. All right, so all of us inside of our minds, we have the ability, if I say add two relatively small numbers together, right, we have our limits, but if I say add 3 plus 2, everybody in here should come up with the 5. Everybody should come up with the 7. Just see how many people were awake, right? Okay, 3 plus 2, we all come up with the 5. How'd you do that? Well, this kind of comes back to the whole thing, how do human beings solve problems? None of us really thought of it, right? You heard 3 plus 2 and you just 5 popped into your head. Okay? But if we slow things down, we realize that somewhere at some point we learned how to add, and we know what a 3 is and we know what a 2 is, and we add those guys together, there's an answer, and we kind of called upon that ability somewhere inside of our head called add nums that takes in 2 parameters and adds them together and spits out a result. That's the add nums function that we have inside of our head. Well, we might want to write that same function. So this guy is a reusable chunk of code that we write once and call multiple times. And these guys can optionally have inputs, often called parameters, that allow the function to work differently each time, or at least produce a different output. So for example, you probably don't have a function inside your head that only knows how to add 3 plus 2. If I call 1 plus 3, you're probably calling upon that same I know how to add stuff ability, and you're coming up with the 4, right? You just took in 2 different numbers that you're adding together. Okay, now in most object-oriented languages, instead of functions, these guys are called methods. Same thing. So functions, methods, subroutines, procedures, these are all the same things. Some older languages had a distinction between functions and procedures. For instance, a function in a language called Pascal returned a value where a procedure did not. Something like that. So a procedure was something that didn't boil down to a value. So for instance, I might say, remember the number 5. So you just remembered it. There was no feedback required. You didn't spit it back to me or anything. You didn't return a value. You had an ability that you know how to remember stuff. So I just basically stored a piece of information inside of your head. I used all of you as hard drives. Should be kind of a demoralizing type thing. All right. So let's go look at the syntax for functions, methods, blah, 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 whatever. Now, a class, let's just kind of give a little bit of a layout here for Java. So in Java, we have this thing called a class. And we're going to keep adding information to this over the next couple of, pun intended, classes. But a class is a collection of, well, let's use the right terms, collection of fields and methods. I'm going to throw this other thing in here called and constructors, but let's not talk about that yet. We'll talk about that probably next class. Okay? Because we're kind of bringing our knowledge up to date with where we were in Python, but in Java. That's kind of what we're doing. So we're zipping through this stuff. But so from our perspective, a field is a variable. So a class is a collection of variables and methods. And really at this point, since we're not having global variables yet, from our perspective, a class is really just a collection of methods. If we go back to our class right here, here's the opening curly brace for our class. Here's the closing curly brace for our class. And if I go ahead and just minimize this method, the only thing that's in between is one method called main. Does that make sense? So this guy is kind of a basket for holding some methods. But I could also have variables in there, but we just haven't had any yet. So now I'm going to go ahead and we're going to look at the syntax for defining another method. And the way I minimize this is there's a little plus minus sign over here. Just kind of a convenience thing. If you finish writing a function and you kind of want to scoot it out of the way so it's not taking up your whole screen, you can kind of do this type of thing. So syntax for functions. We have return type, followed by function name, followed by opening parenthesis, comma, delim parameters, closing parenthesis, opening curly brace, closing curly brace. And then maybe inside here you say something like logic. Okay? Don't worry about this public static stuff yet. We're going to talk about that shortly. But for right now, here's the return type. This is the kind of value that the method will spit out. So our options are anything we can create a variable of, or void if we intend to return nothing. So main does not return a value. We're going to go ahead and we're going to write add nums. So we're going to have a variable here. Now, just for the sake of argument, I'm going to make this guy static. Don't worry why, just I'm going to. Okay? So he's going to be static. But for add nums, this guy's going to return a number. Going to return an integer. It's going to be called add nums. It's going to take an int a and an int b. So 2 inputs. Comma delimited list of parameters. Parameters, inputs, same thing. So I'm going to have to provide this guy with 2 numbers. And what he will do is he will return the first number added to the second number. So a plus b will be whatever value a resolves to, plus whatever value b resolves to, and then we'll spit that answer back out as this kind of value, as an int. Okay? So now up here in main, we'll do it at the very end. That way it's the last thing we see. So up here in main, we're going to go ahead and we're going to we're going to do a system. Well, let's just put it in a variable first. We'll say int answer equals add nums, and we'll pass it 3 and 2. And then we'll do system.out.println answer. That should give us our 5. So there's our 5. I can then call that exact same chunk of code again. I already have a variable defined called answer, so I'm just going to reuse it. And let's add 1 and 3 this time. And we'll go ahead and print out answer again. We should get a 4 this time. So we've called upon the same chunk of code, but provided it different inputs. It gave us a different answer. Make sense? Okay, questions about functions. Now, we did this exercise last semester, but we're going to do it again in here in Java for you to practice. And it was something called FizzBuzz. Probably don't click on FizzBuzz Java because it's just going to give you the answer, but try to write it yourself first. So I'll give you the link to the Wikipedia page for this. All right, so the way FizzBuzz works is you take a bunch of inputs. So this is kind of talking about people doing it in real life. So the very first person has a number. So we're going to go through a collection of numbers. So we're going to have a for loop that goes through a bunch of numbers. Okay, and we count up. So we go 1, 2, 3, 4, so on and so forth. So now any number that's divisible by 3, we replace with the word fizz. So when we get to 1, we'll just print out 1. Get to 2, we print out 2. We get to 3. 3 is divisible by 3, right? And we talked about the mod operator in here, or at least talked about it last semester. So we have this thing called the modulus operator. So 6 mod 3 will give us an answer of 0. 6 divided by 3 will give us an answer of 2. So this is long division. 6 mod 3 gives us the remainder of the integer division of 6 divided by 3. If I say 6 divided by 4, 4 goes into 6 one time with a remainder of 2. That make sense? That's the modulus operator, the percent sign. So when I say divided by, evenly divisible by 3, that means when modding it by 3, it would give you a result of 0. So any number that's divisible by 3, we would replace with the word fizz. Any number that's divisible by 5, replace with the word buzz. Numbers that are divisible by both fizz and buzz. So we'll have an if statement. We'll have a Boolean expression that uses an and. If it's evenly divisible by 3, and the and operator in Java is double ampersand. So A is less than 5 and B is greater than 2, something like that. That's a Boolean expression. So this guy will boil down to a true or false. This guy will boil down to a true or false. And an and is only true when both sides are true. Okay, we did this last semester in Python. So if it's divisible by 3 and 5, we'll get a fizz buzz printed out. So I'll put the thing up on a blackboard, but I'll have you count all the numbers between 1 and 1,000, doing the fizz buzz thing, printing out just the value if it's not divisible by either of those, printing out fizz if it's divisible by only 3, printing out buzz if it's divisible by only 5, printing out fizz buzz if it's divisible by 3 and 5. Make sense? All right, I will see everybody on Thursday. Today is the first day of the student, faculty, staff Bible study. You get free lunch. So if you go down to the cafeteria, there's a little sign-in sheet. Just sign in, say you're going to go to Bible study, go and get your lunch, and take it down to the terrace room. God and grub. A lot of CS people that we go down at 11:30 and eat in the caf first and then walk down. So you're welcome to join us.